In 2.2, we're going to talk about conditional statements, okay? So, conditional statement is a statement that has a hypothesis and a conclusion, okay? So, something that would be like a conditional statement would be like, if it is raining outside, then the sky is gray, okay? So, that's a conditional statement. Usually, you see them written in if-then form. It'll say if blah, 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 then blah, 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 okay? So, the if part of a statement is talking about the hypothesis of what you think is going to happen, okay? So what comes after the word then is called the conclusion. So what we can do is we can take a statement and change it into if-then form, okay? So they just give me a statement. All birds have feathers. There's no if and there's no then. Okay? So what we're going to do, practice doing, is taking this and writing it into a statement that has an if part and a then part, a specific hypothesis and a conclusion. So one way to do this, for this statement, all birds have feathers, and we could say something like this. If an animal is a bird, then it has feathers. Okay? Let me write it with bold. Wrong pen. Not in this lesson. If an animal is a bird, then it has feathers. So I've told you before that geometry is like its own math language. Okay, so a lot of language and logical skills that we use from language, it kind of overlaps in here. That's why we stress vocabulary so much. Right? As you can see on your test, you had to know what bisect was to be able to get those problems right. Okay? So, same is true here with conditional statements. So we took this sentence, which is all birds have feathers, made it into a hypothesis and conclusion. Okay? So the hypothesis of this statement is an animal is a bird. That's an S there. I know it looks crazy. Okay? So that's my hypothesis, is that an animal is a bird. The conclusion about that hypothesis, then it has feathers. Okay? So it comes after the if, it's the hypothesis. After the word then, there we go, fix it for me. Then, after the word then, is the conclusion. Okay? So y'all help me see if we can help number 2 into a hypothesis and a conclusion. When two angles are a linear pair, they are supplementary. So how do you think we could say that, Noah? That's exactly correct. So if two angles are a linear pair, then they are supplementary. So you're just basically changing your sentence to have an if and a then. Okay? So the next thing we're going to talk about is a negation. A negation. So I want y'all to write down that definition for the word negation, please. Negations are super simple, y'all. A negation just means the opposite. Okay? So, if I say a ball is red, what's the opposite of saying the ball is red? Okay, so let's just say, a counter example would be the ball is blue or purple or green or whatever. Okay, it doesn't matter what color the ball is. The negation would be any color besides red, right? So the negation is not the ball is purple. The negation would be the ball is not red. Does that make sense? So you don't just throw in another color in there because that kind of changes the meaning, okay? So if the sentence is the ball is red, The negation means it can be anything besides red. So you say the ball is not red. So usually if you just add the word not into the sentence, it negates it. Or if it has the word not in it and you take away the word not, then that's usually the negation. So the next example says the cat is not black. What do you think would be the negation of that sentence? Yeah, to negate it, just take out the word not, and it's as simple as the cat is black. That's it. So if it doesn't have the word not, if you put that in it, it negates it. If it does have the word not, take it out. Sound good? All right. Let's talk about a converse. You will hear me talk about converses of a statement all the time. When we start doing proofs, when we start seeing a lot of theorems, which we're going to start seeing starting Tuesday. Lots of theorems starting Tuesday. So if we swap the order of the hypothesis and the conclusion, that is called a converse. If you swap the order of a hypothesis and a conclusion, that is called a converse. So it's really easy if the statement is already in the if-then form. So all you have to do is take the if part and put it where the then is, and take the then part and put it where the if is. Yes?
All right, Irving, Caleb Rankin is on English to check now.
Okay, thank you. All early. Watch the video. All right. So here we go. Here's our statement. I don't know why it's blue. I apologize. It's black. It's blue. So they're going to give us a statement, and we're going to practice finding the converse. You might want to take your book. If I had them written down, I'd give you the problems, but I don't. And give me a second, I can. Said I could. See, this is why I don't like to check it out, because it interrupts my teaching. Nope, come here.
Hold on. This is homework.
Mm-hmm.
Technically, the clock's slow, so
It's school time. There's one. Don't forget vocabularies due Tuesday. There you go.
have a good
You too. Have fun teaching yourself. All right. Converse. That's where I'm at. All right. So he had the statement, if you are a guitar player, then you are a musician. Okay? Now, to get the converse, we're going to swap the hypothesis and the conclusion. So what's the hypothesis of this statement? You're a guitar player. So what's the conclusion? Then you are a musician. So to write the converse, we swap the order. We put the hypothesis first and write it with the if. I mean the conclusion first and put it with the if. So if you are a musician, then you put the hypothesis in the conclusion spot. Is that always true? No. I consider myself a musician. I play the piano. I'm not a guitar player at all. I don't even like holding them. They make me nervous. Okay? And my husband has probably 30 of them, and they still make me nervous. Because I'm afraid I'm going to break it. And I know how much they cost. Okay? So sometimes a converse is not true. Alright? It's not always true. Sometimes the converse is true. Okay? So if something has a converse that is true, then it's called something called a biconditional statement, which we'll talk about later. Okay, so here's what you're going to have to do on your assignment. They're going to give you a statement. It's not an if-then form. Okay? They gave us soccer players or athletes. We've got to make that into a if-then hypothesis statement. And then we're going to find the converse. Okay? So how do you think I can make an if-then statement about soccer players being athletes? Noah.
If you are a soccer player, then you are.
Yes. Or you could even change it a little bit and say if a student is a soccer player, then he is or if a person is you don't have to say you. You know what I'm saying? There's other words you can put in there to make it mean the same thing. So I'm going to say it like he said it because I liked it. If you are a soccer player, my handwriting is terrible, y'all. Then you are an athlete. So, usually if you write something in if-then form, you kind of go in order. We mentioned soccer players first, so we want to put that first in our hypothesis. Then you are athletes. It came last, so we kind of want to put that in the conclusion. So when you're writing your if-then statement, kind of go in the order in which they've mentioned everything. Okay? So, remember for a converse, we swap the order. Boom. So what do you think we're going to say first for the converse? If you are an athlete, then what? Then you are a soccer player. Is that converse always true? No, because you can play any sport and be an athlete. And that includes cheerleaders, in my opinion, because I can't even turn a cartwheel. Seriously, cannot turn a cartwheel. Never could my whole life, and if I tried to right now, I seriously would fall on my face because I have no upper body strength. All right, so y'all try this one. Write the converse. They gave you the if-then, you tell me the converse. If a dog is a Great Dane, then it is large. Tell me the converse. They can be slightly different, but I expect them to mean the same thing. All you do is take, if an animal is large, or if a dog is large, then it is you just swap the meaning.
You can swap somewhere.
Yes. Yeah. Okay, so all you have to do for a converse is swap what this one's saying with what this one's saying. Okay? You take it the if and then you swap them. So we could say for the converse, if a dog is large, then it is a what? Did everybody get something like that? I need to finish my words. My spelling is not good on Friday. All right. So, this term right here, biconditional statement. If a statement in if-then form and the converse are both true, then we call this something called a biconditional statement. So if a statement and the converse are both true, then it's called biconditional. Is that Great Dane statement both true? Are Great Danes the only large dogs there are? No, they are a large breed of dogs, but there's also Saint Bernards that are large. German Shepherds are large. Yes, there's lots of other dogs that are also large. So that would not be a biconditional statement. Okay? But there are statements that sometimes their converse is true, especially in math class. And so if you see the words if and only if, that means that statement and the converse are both true. Okay? So if you see the statement if and only if, then that statement and the converse are both true. Okay? So if it says if and only if, that means it goes both ways. All right. And I'm just going to go ahead and warn you as you finish and writing that up, you will want your book out for section 2.4. And that will make us do a little less writing. Okay, because there's some about 10 postulates. And we're just going to look at the book for it instead of writing them down. What? We are. Well, if and only if. So it'll say something like, okay, what do we know about? Perpendicular lines. Okay? So you would say something like, two lines are perpendicular if and only if they form right angles when they intersect. Okay? So they could say, so if lines are perpendicular, then they form right angles, or you could say it the other way. If two lines intersect and form right angles, then they are perpendicular lines. So something like that would be an if and only if statement. It works both ways, no matter which order you say it. Yes.
No, Jared's checking out.
Thank you. Shh. All right, I'm going to swap over to section 2.4. Hang on, Dale. I'm getting your assignment. Y'all can just be prepared. You're not leaving my room without the assignment. If you're getting credit for being here the whole time, you're going to get the assignment like everybody else too. It's only fair. Anybody. I don't care. Hush. This plus your vocabulary is due Tuesday. All right, so get out your book and turn to page 96. It's on there highlighted. And please go ahead and read over those postulates. In the green part of the book on page 96, read those postulates. Again, I'm not going to make you write those down because they're in the book. You might want to snap a picture of them if you don't want to flip, because there's a few questions on your assignment. I think only 2. I'm only giving you 2 homework problems on this, I think. So one postulate says through any 2 points, there is exactly one line. Next postulate said a line contains at least 2 points. Postulate 7 says if 2 lines intersect, then their intersection is exactly 1 point. Postulate 8 says through any 3 non-collinear points. What does non-collinear mean? Not on the same line. There exists exactly one plane. Number 9 says a plane contains at least 3 non-collinear points. So for it to be a plane, it has to have 3 points not on the same line. Number 10 says if 2 points lie in a plane, then the line containing them lies in the plane. And postulate 11 says if 2 planes intersect, then their intersection is a line. Okay, so that's going to make a little bit more sense with the picture. So this is like two separate pictures here, okay? I'm going to draw a red line right there so you can separate them. I have y'all froze, apparently. Okay, so that's separated. So let's look at this. Now, do you see any planes drawn in these pictures? No, you do over here, but not in number 1. Y'all see those? Okay, now look at those postulates on page 96. Look in the green area on page 96. It says if, and I've got two separate points right here, then what's happening in the picture? You're drawing a line through the points, right? So which one of those postulates, now again, it's not a postulate that's talking about planes, it's talking about points in a line. Which one of the postulates says something about 2 points making a line? I think it's 5, don't y'all? Because it says through any 2 points there exists exactly one line. Well, that looks like that's represented in that picture. Don't y'all agree? So this would be postulate 5. So what you're going to be doing is they're going to give you a picture of something and you're going to pick which one of those postulates it is. Okay? So look at number 2. Look at number 2. So let's look and see what's happening. They're in planes, so it'll be one of the postulates that mention planes. So I think that's postulate 7 through 11. Okay? 7's not a plane postulate. So postulates 8 through 11. So I've got 2 points in planar, and then I've got 2 points with a line through them. So which one do you think says something about having 2 points, and then they make a line? I think it's 10 also. If 2 points lie in a plane, and that's what we got, 2 points in a plane, then the line containing the points lies in the plane. So there's the line going through the points, and that's in the plane as well. So I think that one's postulate 10 as well. Do y'all agree? Me too. Okay, so your 2 questions you have for your homework for this section, that's what you're going to do. You're going to look at the picture, and then you're going to turn back to page 96 and see which one of those postulates you think it matches with. All right? Obviously, if there's no plane drawn, you know it's going to be postulate 5 through 7, right? If there is a plane drawn, you're going to use any of the postulates 8 through 11. Does that make sense? Yeah. Okay. Last thing I think I want us to do is draw some pictures using our symbols. Now, this is where we're going to need to know our symbols, okay? So they're going to give us a statement using some symbols in geometry, and we're going to draw a picture that represents those symbols. So I want y'all to write down number 1 for me, please. Now remember, we've done this before with the letters and the symbols, and I had them written on the board for some time, and y'all have a little sheet that you're supposed to be keeping up with in your notes about symbols. All right, so I'm going to point to one of these symbols. I want y'all to tell me what it means, okay? What does this symbol mean? A line. What does this symbol mean? A segment. All right, point W is a point. And this means segment is to this segment, right? Right? Okay, good. So maybe we have enough information. So it says line TV. Okay, so that means you need to draw a line. Now, lines have arrows on them, right? So draw a line forever. My pen's missing it. So it needs a point T and a point V on it. Intersects segment PQ at point W so that TW and WV are congruent to each other. So I got a segment PQ intersects that line at what point? W. So this place they intersect is at W. So that TW, which is right here, this segment, and WV, which is this segment, are congruent to each other. So in other words, W is the what? The midpoint. Yes, PQ is the bisector because it cuts it in half, right? But point W is the midpoint of section TV. Right? Or segment TV. So how can I show congruent? That symbol's important. How do I show congruent on a figure? Y'all remember? There's one thing I can do to my figure to show they're congruent. Well, no, it's not perpendicular because this segment technically could be slanted. This can be a slanted segment like that. Right? Do what? Yeah, those little tick marks. Y'all remember those? I'll do mine in red. So if you see the little tick marks right there, that means that segment's congruent to that segment. Okay? So if it says it's congruent right there, then you need to show on your picture that it's congruent with those little tick marks. All right? If you're doing it for angles, you put little arcs in the angle, and I'll show you one of those whenever we get to doing more angles. All right, here's a nice symbol we need to add to our list. An upside down T looking thing means perpendicular. So perpendicular lines intersect to form what? Right angles. Okay? So what is this symbol right here? A ray, right? With the endpoint of F, right? And this is a segment, and this means perpendicular. So ray FH is perpendicular to segment EG at the midpoint M. So, to me it sounds like we got segment EG hanging out right here. My bad pen, sorry. EG. And I have this ray called FH with the endpoint of F. And H can be anywhere. H can be up here, or H can be down here. But it intersects the segment at the midpoint M. So there's two more symbols I need to show on here. How do you think I can show that that ray is perpendicular to that segment? Not a tick mark, but what? What does perpendicular mean? It makes a what? A 90-degree angle, right? So I did the little box to make a 90-degree angle. Okay? And also, midpoint M means what? It's the middle. So that means segment EM and MG are congruent to each other. So how do we show that? And then we do the little tick marks. Okay? So make sure when you're drawing a picture, because I think you're going to have to do that for me on your quiz next week, that you show everything. So I need to see it's a right angle for perpendicular. I need to say tick marks when you see words like bisector, midpoint, or congruent, or stuff like that. Okay? All right, that is all we're doing today. Do what?
The ray be down.
Yes, it could be tilted sideways the other way. The ray could be to the side, and the segment could be going somewhere else. Okay, so y'all, this looks like more than this. I'm going to end my video. Have a good day.